Hello and welcome to the Data and AI Summit. My name is Maarten. I am team lead for the data science and engineering team at the BeLux entity of Delaware, an IT consulting company founded about 15 years ago here in Belgium and is now delivering global IT services. The idea behind this session is to give you an insight into our lessons learned when dealing with modern data use cases. The idea came from a type of workshop that I give quite often at customers, and I try to condense the workshop in the next 20-25 minutes. Now, instead of just talking about these lessons learned in theory, I will be applying them to an actual customer case that I personally designed, architected, and guided through implementation as a project manager. So let's get started. When we think modern data use cases, I always like to take a look at the market. I like to understand what vendors such as Microsoft, Databricks, SAP are telling me. But this year we did a survey of our own. We asked our customers, what are you doing with data? And we were actually quite surprised. There's a lot of ambition in the market, and over 90% of our customer base indicates that they are currently doing data-driven innovation. Now, at the same time, we also noticed something else, and that is that a lot of customers are struggling to get to a certain level of maturity. We found out that just a little bit over 3 out of 5 companies could tell us that they get some form of measurable results from their data efforts. Now, a result can be both positive, a success, but it could also be a lessons learned from a failed project. So when asked about success, then we got that not even 1 out of 3 companies was able to tell us black on white that their data efforts were successful. Now, successful project could also be a POC, can also be an experiment. It might not make its way into production. So the final question was, did your data efforts made its way into production? Did you get true business value from it? And then not even 1 out of 5 companies could tell us that their data efforts made it all the way into production. Now, why is this number so low? And how can you become part of this 17%? And to do this, we first need to understand why so many data projects fail. And actually, this is quite easy. When we think about modern data use cases, then we are confronted with a lot of technologies, concepts, platforms, vendors, and companies lose global overview. They take in technology and they create what I like to call a data zoo. On average, we see that companies have 7 different tools in-house to do something with data. From my personal experience, I even had one customer who had 11 different tools licensed just for data visualization. Now we are confronted with all these technologies, and this actually brings me to the first lessons learned. That is that when you're doing a modern data case, please start with the problem, never start with technology. Technology is just a means to an end. If you don't have terabytes of data lying around, then Hadoop or Spark might not be the tool for you. If you don't have high volume multi-million streaming cases, then, well, going Kafka Spark streaming might also not be the case for you at this point in time. So please start with defining your business goals, defining your metric for success, and then move on from there. Also dare to call stop. It can happen that at a certain point in time, you hit a roadblock and you first need to fix this roadblock before you can come back to your problem. So like I said, I will be applying these lessons learned towards an actual customer case. And the customer that I have for you today is a customer called Fluvius. Fluvius is the merger of Eandis and Infrax, and they actually unified the Flemish energy market. So Fluvius is the single responsible party for managing the electricity and gas grid here in Flanders. Now, this gives Fluvius a unique position, but at the same time, it also gives them a lot of responsibility. People are looking at them to innovate, to gain climate goals. And one of the things that Fluvius understood, what they needed to get to this point, is that they needed to become a neutral data broker about energy data. To get to this data, they were actually installing the things that this guy is installing right now. These are the new digital meters for electricity and gas that are currently being rolled out in Flanders. Now, I know there's a lot of controversy around these meters. We're not going to talk about that part, but they actually form quite an interesting case to build a data platform with. So let's take a look at what Fluvius wants to achieve. Fluvius wants to build a core data platform that can support a wide variety of use cases. Vision-wise, this means that Fluvius wants to interface this data and be able to scalably share this data both internally, but also with external players. Now, like I said, this is a vision. This is way too broad. The first problem that Fluvius came to us with is that they wanted to create a customer portal where you, as an end consumer, are able to access up to 3 years of your consumption history. And I mean, this is quite a well-aligned case. I know it's everybody can imagine this. You go to a website, you log in, and you effectively get an overview of your users' history. So, I mean, this already gives quite a lot of value in a sense that suddenly you have these millions of households that are able to access this data, verifying if it's correct, verifying if there's maybe an issue with the digital meter, and essentially building together with you on the data quality of your data estate. So this is the use case we like to tackle. Let's take a look at the input side. And the input side is, of course, the digital meter. Now, these meters, they represent quite a lot of data. First, simply because of the sheer number of meters that are going to be installed. After full rollout, we're talking over 7 million IoT devices that will be in the field in Flanders that we need to take in. Now, when I say a lot of data, I truly mean that they send a lot of data. We're talking up to 12 terabytes of data, not per year, not per month, not per week, but every single day, we can be confronted with the case that we get 12 terabytes of data into our data platform. Now, combine this with the requirement that Fluvius is building a customer portal where you can access up to 3 years of your users' history. This means that we're looking at a data platform up to 12 petabytes of data. It gets even more interesting in the sense that consumption data is, of course, your data. It's person bound. So we have this thing called GDPR and also other strict regulations from Belgium and Flemish government that this platform has to adhere to. So to summarize, Fluvius wants to create a core data platform that can ingest data from over 7 million IoT devices, up to 12 terabytes of data a day. Oh, and by the way, it has to be fully GDPR compliant. Now, when looking at a case like this, people with some experience might tend to look at a golden hammer. You might like to go for the things they already know and try to tackle all these problems with the architecture, with the components they already have in place. Now, this idea brings me to the second lessons learned, and that is that a golden hammer approach does not exist or does very rarely exist. Please, when thinking modern data use cases, think about creating a portfolio. Try to create a true turn the dial approach where you have the flexibility to scale up or down, where you have the flexibility to ingest multiple data sources into your data estate. Now, what do I mean with this in practice? Let's take a look at the most common data flow I think there is, and that is the classic data warehouse flow. Very well known. You have your data sources, you do some ETL on it, you load it into a data warehouse, and then you finally build some reports, some analytics on top of it. Now, this classic data warehouse comes with some challenges nowadays. First challenge is that we are confronted with an ever-increasing data volume. Especially with the digital meters, we will capture quite a lot of data. And from my experience, a typical data warehouse is built very monolithical. So this means you can scale up, but scaling out isn't that easy to achieve. Second challenge that we see is that we find ourselves in the need to collect and combine any data. Especially in the Fluvius case, this is very important in the sense that today we have one hardware vendor of the digital meter. Maybe in 2 years' time, there can be multiple. So classic data warehouse flow does not play always very well with collecting all these different types of data, consolidating all this input. Third challenge that we see is that people are moving away from a purely consumption view. They're moving away from being a data consumer to becoming a data explorer. You have data scientists within your company who want to take a look at the raw data before it's cleaned and put into your data warehouse to maybe check if you've missed something, if there's still more value in your data that you aren't using today. And the fourth challenge is across the board, and it is that real time is becoming the standard. It used to be okay that you had a nightly job and that the data in your data warehouse was a couple of hours old maybe. Nowadays, if you click a button, if you ingest an event, you want to see the impact of this event immediately across the board. Now, tackling all these challenges one by one might be feasible with your current data warehousing setup. Now, if you look at all these challenges at the same time, then for one, you get quite a messy slide. But this mess is also what's happening with your data warehouse. So what I like to do in cases like this is I like to take a step back. I like to think about conceptually, what does a data flow mean? What different steps do you have in any data flow? And then again, you have your sources on the left, your use cases on the right, and you have your different steps of your data pipeline. So you ingest data, you store it one way or another, you process it, and finally you serve it back towards your consumer. Now, if you map the Fluvius process to this, then for the ingest part, we see that we will need to be able to ingest up to 7 million or over 7 million IoT devices. Storage-wise, these devices will send us quite a lot of data, but not from day one. You don't install 7 million devices in 24 hours. So this volume will increase continuously. For the processing part, if your storage can scale, then for sure the processing should also seamlessly scale. You don't want to be confronted having to review your infrastructure week by week just to cope with increasing data volumes. And then finally, for the serve part, Fluvius wants to build at this point in time an API layer that can handle at least 1,000 API requests per second. Now let's map out some technology. Let's try and solve the Fluvius data pipeline. And let's start with ingest and store. So when thinking about the use case like this, I know some people of you are currently shouting at your screen and telling me, okay, just use a data lake. And yes, a data lake is a very solid technology, but what I would like to say about a data lake is please avoid the data lake pitfalls. It's a very solid technology, a very solid concept, but at the same time, avoid these pitfalls, try to be aware of them, and try to get your data lake implementation to succeed. Now, what do I mean by this? I know, yes, data lakes are often the go-to solution in cases like this because they have a lot of advantages. Number one being they're designed to handle a massive scale of data. Now, together with this design for massive scale of data, they also offer optimized performance on this data estate. Another major advantage of a data lake is that it offers you quite a lot of integration flexibility. You can pretty much store anything in a data lake, whether it's an image, an IoT message, raw data, you can just put it into your lake. And then fourth, a data lake is quite a cost-effective way of storing a large volume. Now, reality is, and I got this number from Gartner, is that easily 60% of all data lake implementations fail. I even came across a video interview with some execs actually telling, okay, this number 60%, this was what people were telling us black and white, but reality feels that this number is easily 80-85% of data lake implementations that fail. Now, why is this? This is because every single advantage has an equally big pitfall. We call it a data lake, data ocean. We simply always refer to a data lake as something that you can drown in. This is also what happens quite a lot. A data lake becomes a data swamp, answering old questions, questions that are not relevant anymore today. Yes, we have optimized performance, but at the same time, we also need the capabilities, the right best practices to leverage this performance. It's quite easy to put something on a lake, get it back, but it's not always that easy to apply the right best practices. Yes, we have integration flexibility, but at the same time, this also means we have schema on read. If different teams, different people are working on your data lake, then they need to understand the structure. They need to understand what's in your lake to make sense of it, or they will jump to the wrong conclusions. And yes, a data lake is very cost effective, but this is also the major reason why a data lake is very often mispositioned as a strategy. A data lake is a technology, it's just a means to an end. Implementing a data lake will not solve your data problems. If you put everything in your lake and you don't do anything with it, you just created one big sunk cost. Now, as long as we are aware of all these different pitfalls, we can actually make our data lake implementation succeed. So at Fluvius, we really like the advantages. We're aware of the pitfalls. So let's take a look at the next step in our pipeline, which is, of course, processing. Now, when asking customers, what do you expect from a processing component, there is that, they always tell me it has to be fast, it has to be scalable. They never tell me that they want to focus on collaboration. Well, this is actually common sense. If you're building a huge data estate, if you're consolidating company-wide all your data into your data lake, if you have a processing component that's not able to enforce collaboration within your company, then again, you only have one big sunk cost. So what does this collaboration aspect mean in practice? Um, we want to aim at one unified analytics processing engine. So this means in practice, again, you have some data sources on the left, you have some use cases on the right, and we need to fill in the blank to understand what requirements do we want for this processing engine. And the first pillar is, of course, like I already mentioned, is that you want to have a collaborative workspace. Within your company, you will have different personas. You might have a business analyst who knows your process very well. He needs to be able to communicate his wishes to a data scientist who can help him with a proof of concept and experiment. And once successful, those two personas want to pass it on towards a data engineer to put the experiment into practice so that you get business value from your data efforts. Second pillar, and something that a lot of companies forget, when you're doing data innovation, when you're introducing new tools, you don't want to forget what's already there. You have governance in place. And in any data pipeline, you will have some ETL or ELT. You will have jobs. You will have monitoring capabilities. Um, Maybe you have an ISO certified change and release management process. So you also want to include some DevOps on top of it. So everything that you have built within your company with respect to governance, with the results of best practices, you also want to bring this along when you're introducing a new engine, a new component into your tool stack. The third pillar is, of course, to have a solid runtime foundation. We want some data lake management from this engine. We want it to be serverless, to scale without limits, and especially we want it to pay and scale as you go. If today you have 1 GB and within a couple of weeks you have 1 TB, you don't want to pay now for 1 TB of capacity. You want to scale and pay together with your increasing needs, with your increasing use cases. Now, all these functional, non-functional technical requirements at Fluvius, we were able to tackle these by introducing Databricks on Azure. Now, Azure was a choice of Fluvius in the sense that Fluvius considers an Azure-first strategy. But Databricks as a technology stack on Azure, as a tool on Azure, was able to cover all functional needs, all technical needs that Fluvius had for their core data platform. So let's take a look back and how does the data pipeline at Fluvius looks? So we have the digital meter or consumers on the other end. How will we fill in the blanks? Let's take it left to right. So first, ingest and store. For this, we chose for an Azure Data Lake Gen 2, and we combined it with Delta Lake functionality. Now, why is this approach successful? This means that we have one unified, consistent way into our data platform. It's also a very cost-efficient way for storing the full detail. These digital meters will send us checksum information, message overhead. It's quite a lot of information. We don't need this type of information in every single use case. Now, when we think about it, and we want to fill in the blanks for the serve components, a lot of people will try to also reuse the components that they're using in the storage layer. And this actually doesn't always make sense. The ingest and the store part is a usage pattern that is very heavily focused on write, getting your data into the data platform, while a serve use case is actually more focused on a read pattern. So for the serve use case at Fluvius, we went with an Azure SQL database as a caching layer and Service Fabric to develop our APIs. Now the components itself, they actually don't really matter. I just want to emphasize here is why is this approach successful? Why is decoupling storage from serve successful? That by doing this, you can create workload-specific platforms tailored at a specific use case within your company. Can be APIs, can be data warehousing, can be machine learning, but decoupling these two means you can truly differentiate based on your various use cases. This is, of course, that you filling the blank, the processing components, with something that can act as the glue between these two. And I'll basically already gave it away. For the processing step at Fluvius, we chose Azure Databricks. Now, why is this successful? Why is this a good component for their data platform? Is that it gives Fluvius a unified runtime for development, for experimentation, but also for collaboration on their data estate. In a lab environment, in an experimentation environment, it provides us with a one-click setup. And because we're running Databricks on Azure, we also get quite a nice advantage from Microsoft. Microsoft takes in Databricks as a first-party service on Azure. Now, this means that you get quite a lot of native integration with other Azure components. If you want to cover security with Active Directory, it's there. If you want to do secrets management, service principal management, you have Key Vault, it's there. If you want to connect to various data sources, SQL database, Cosmos database, Data Lake, All the connectors are there provided by you, by Microsoft. Now, again, these are all technological components. What did Fluvius get from this data portfolio? Well, by implementing this data portfolio, Fluvius got an effective way to drive innovation in the Flemish energy market. First and most important part is by having this data portfolio, this meant that they were able to bring consumption insight and, more importantly, consumption awareness back towards millions of households in Flanders. By implementing this data platform, Fluvius was also to achieve a lower barrier for data and market-driven change, not only internally at Fluvius, but also allowing external players in, of course, a legal framework agreement to also participate in innovating the Belgian energy market. Now, there's one last part, and it's not really a functional one, but it's quite interesting to understand. We're building a data portfolio. It will contain a lot of components, and to some people, this might seem very complex. But we did an architecture study before we started the project at Fluvius, and what we saw is when trying to create a golden hammer approach or single stack solutions to cover the same functional needs, then we noticed that every single solution was easily 20 times more expensive in terms of TCO when compared to the data portfolio. So yes, it might seem complex at first, but at the same time, in the long run, it will pay itself back. Now, what do I want you to remember from this session? Please always start with the problem. Never start with technology. Technology is not a strategy, it's just a means to an end. Second, a golden hammer approach does not exist. Please focus on a portfolio approach. Please focus on a true turn the dial approach so that you can differentiate. A data lake, beautiful technology, beautiful concept, but please be aware of the pitfalls, as they can make your project fail quite easily. And lastly, and certainly not least important, please put an emphasis, put a focus on collaboration. You are building a huge data estate. You want to be able to get value from your data estate. And the only way that you can achieve this is by focusing on collaboration, allowing your entire company, all your people to work together on your data estate. Now, if you're interested to learn more, please feel free to check out delaware.ai. This is our public-facing AI-branded website where we put in all topics around data-driven innovation, but we also put in some customer stories that we can share to give you some inspiration about doing data-driven innovation at your company. This leaves me with nothing more to say than to say thank you. Thank you for attending the session. Thank you, Databricks, for organizing the summit and for allowing me to speak. Now, if there are certain things that you've missed from the presentation, or if you liked it, please let me know via the feedback form. Your feedback is very valuable to us. We really like to understand where we can improve. And I like to also understand where I can improve to make this content even more relevant for you in upcoming sessions. Thank you and enjoy the rest of the summit.